Hey everybody, welcome back to the Edge and Flow podcast. I'm TJ Schwartz. I'm here with Lucas Burnley. Today we're talking about knife bevels. So the actual part of the blade that tapers down to the edge, and it's the crux of the knife maker, of the knife manufacturer, of anyone
Kind of just
who
knives, right?
yeah,
It's a
yeah,
blade grind.
exactly. If you
Like,
take we talked about it before, if you take a CAD file or a design to a CNC facility manufacturer and you ask them to make it, they'll if they tell you they can do it all, including the bevel, they're
which
probably
they will.
lying.
Yeah.
Yeah,
They
they're
just don't know.
probably
I don't think it's intentionally
yeah,
lying. I just
yeah,
think they see a shape and they're like, we can do that shape.
yep, yep. But there's the nuance in a knife bevel is profound, and yeah, we want to talk about it today.
All right. This is exciting. We get to
Yeah,
talk about it in like two different standpoints too, like manufacturing side, like handmade side, and kind of everything in between, right? Did
hmm
you have kind of a direction that you wanted to go as like, I mean, we're not talking about like grind functions, right?
hmm
We're talking
yeah,
about like how to achieve this or
yeah. How
different
to
ways they are
execute,
achieved.
make, manufacture. From the standpoint of the maker, how do you accomplish that shape cleanly? Not
Right.
necessarily what's the purpose of it, or in the field what's the best shape or whatever. That's not what we're talking about. We're talking about making it, grinding it, milling it, whatever it takes.
Totally. I like to think of it as an any means necessary operation. There's a lot of thought around like freehand grinding, grinding with fixtures, grinding on a mill, like all like everybody kind of has an opinion. And like my opinion, for what it's worth, is that like you should just do what works for you.
Yeah,
Right.
yeah. Well, it's
Um,
interesting because it's like when I came into the industry, there was a ton of, and this was 10 years ago for perspective, there was a ton of people it was like a divide between freehand and jig grinding. So
totally.
both of these grinding applications were on a belt grinder. So we should be specific
Make some
about this.
distinctions. Yeah.
Most of the time, when you make a bevel in a one man shop or a custom shop, you have a belt grinder, which is a usually 2-inch wide belt, 72 inches long. So a big loop goes around a couple of pulleys and across either a wheel or a flat surface and various grits. You spin that thing, you grind the bevel. So
Right.
that's like your most generic making a bevel way of doing it. And some people hold it freehand where it's like they're not using a guide, they're just eyeballing it. So it's like you can just feel the belt and actually put a bevel on it, which is an amazing skill. But then, like I said, 10 years ago, there was people who also would set up like a work rest and have an adjustable angle plate fixture of some kind where it's being held at a consistent angle. And so they're still using some feel, but the angle is mechanically confined, I guess is
It's
the way of putting
confined
it.
is actually a really good way to look at that type of fixturing. So there's a bunch of kind of variations in between, right?
Yep.
So like
Yep.
you have people that grind freehand and like they use one hand and then they are resting a blade on like a finger and a thumb. And
Yep.
then you have like I use a push stick when I'm freehand grinding. That keeps me from burning my like blade support hand.
hmm
Gives me the same amount of control. I keep my thumb on the blade, but not my finger. It just is like it is a little bit of support,
Yeah.
right? Then there's other things that people have done, like there's these work rests that almost look like something that you would grind a like a chisel on or something, where it's like a round
hmm
bar.
hmm
Um, the
And
beauty of freehand grinding in general, like if there is, right, is okay, there's a skill to it. This is actually less important to me than the flexibility that it gives you. So there are certain grind types, like if you're doing like a compound recurve hollow grind,
hmm
like something that is essentially shaped like an S,
hmm
that is very hard to fixture grind,
yeah, exactly. It
right?
requires degrees of motion that if it's that unconstrained that you can
Right.
make that motion, then it's not on a jig.
Right. And I'm
So it's
sure
like,
that somebody out there like either has fixtured for that or could. Like I've thought
hmm
about it where you have like it's like a you have a an articulating fixture that has some type of
some kind of bearings in it or something.
like pivot and slide to where you're actually able to create like this really organic shape.
hmm
Um, but I just do it freehand.
Yeah. Well, Yeah, exactly. And it seems like 10 years ago when I first came in, there was that division of like if you use a jig, you're one type, and if you use you go freehand, you're another type, and there was like a
Right.
lot of heat and friction and like argument in the knife scene about
That's
that.
so ridiculous.
Do
It's
you
from,
think
and
it's
generally it's from hobbyists. That's the
right?
thing. Those
Right.
type of thoughts are generally from someone who is newer or is not doing this as their profession, right? To
Mhm.
have that type of
Right.
opinion, there are exceptions to the rule. And I say this because for about the first 5 or 6 years I was making knives, I would use the fact that I freehand ground without fixtures as a show topic of conversation with
Mhm.
customers. Like, oh yeah,
Mhm.
they're all freehand ground, because I was doing these wild curvy grinds and I was really proud of them.
Mhm.
You move forward from that, and I realized I was like, hey, this is actually not something that I feel like I should, I don't know, like present as like a superiority because other people are doing beautiful work and grinding with fixtures. And I was like, how can I like frame this in a way that's not like creating a negative for the way that someone else works? And now I have a very different view on it because I experimented with fixtures and I saw kind of like what they were, how they functioned, where they fit in my work,
Mhm.
and the fact that they are essentially still freehand grinding. Um,
Mhm. In some ways, yeah, and I guess I should say this like Luke here, Lucas Burnley is the 10,000 hours of freehand grinding type guy compared to me, who I've probably freehand ground maybe 50 knives in my life. And so that's I don't have the freehand grinding skill. I can do it, but the repeatability is not there for me. And I've done the jig grinding and then other processes down the road that we'll continue to move towards and talk about in this conversation.
right.
But but you're the expert on the freehand grinding in my book. So
Well,
um,
it's fun because I've gotten to be on both sides of that conversation, and I had when I was first making knives, I was very proud of the fact that I
mhm,
freehand ground. I
very
was
it's impressive.
also yeah, I was also in my early 20s, and as you kind of move through your career, you see that longevity is something that if you love your craft and want to be involved in it for a long time, creating systems that are maintainable as your physical ability changes, then
Mhm,
there's a huge amount of value in that. The first time that I ever was exposed to fixture grinding was working in Bob Terzuola's shop,
mhm,
and I saw the power and like the consistency of that process. And I was just like, okay, like I saw how he did it and like how it was still controlled by his hands and how the motions are essentially the same. But I also saw like where in that process there's limitations. Like if you have a fairly straight blade, if you have a certain shaped shoulder. But that I think is where I said any means necessary,
mhm,
figuring out the process that gets you to the work that you want, right? The
yep,
end result is to me what is like
right.
the authentic impressive component of
The
blade
end
grinding.
product is king.
It's the
It's
end
like
product. Yeah.
what is the result? Yep.
Yeah.
I agree with
Exactly.
that. Yeah, and so I guess we can zoom back out and go, what if we take like a almost granular approach to knife bevels, starting with like the simplest way you could possibly do one, all
Yep.
the way up to like the highest tech, most automated known ways that we are aware of.
Sure.
I was thinking that'd be a cool way to frame like this conversation, I guess. So we talked about the 2x72, which is
Yep.
I would say one step above the file. So the file it would be
Or
probably the
one step.
first. Is
I'd
there
put
other
it.
steps?
I think there could be some other
Okay.
steps.
Okay,
Okay.
let's go into that.
But
So
let's go to the file.
step
File.
1 file. That's like if you have $50 and you want to make your first knife and you're not going to buy a $1,500 to $3,000 grinder, a file. So a piece of
Right.
soft steel, annealed, not heat treated, a hard file of some description,
Yep.
and go into town with a file.
Yep. Which is still like if you look at Wolfgang Lochner's work, he shapes everything with files.
Interesting.
And you would look at it and it will blow your mind because they're these amazing kind of almost architectural, like fluted, polished details
Hmm.
um, that
I'm not
would
familiar.
be insanely time
Hmm.
consuming. Just a basic bevel. Like I think actually, if you go back like to How to Make Knives by Lovelace and Barney, which is a fantastic book, they have like a whole section on like, here's how you do a hunting knife with a file,
Hmm.
right?
Interesting.
So there were people that were making a living by making knives with files
And then there's also the
in
conversation
the
of
modern age.
freehand filing versus jigged
Oh,
filing. It's going to apply to almost all these, but there's a way
right.
that I've seen. There's a guy on YouTube, Gough Custom, Gough, and he has some
Mm-hmm.
awesome tutorial videos. And he has a file jig that he made out of like 2x4s and like a big eye bolt. And so
Oh, I've
use
seen
this
that.
eye bolt and like a guide rod, and so you can do a file bevel that's actually really repeatable and really clean. It's the
Right.
same concept as like most knife sharpeners that a lot of people use, is the guide rod and whatnot.
Right.
Um,
Basically, you're able to maintain a consistent angle.
mhm. Yeah.
One interesting, just to like touch back on fixture grinding, one interesting benefit of fixture grinding is that you can use a different belt progression
Yep.
than you can if you're freehand grinding because it's more controlled. I wonder if the same would be true for files because
Possibly.
you're essentially following the same path repeatedly.
Hmm.
If your polishing process can like be made more efficient with a
I bet. I bet it
filing
would.
guide.
If you went from a like course file down to like a CBN
Yeah,
sanding
something
almost
like
type
that. Yeah,
file. Yeah.
where
Yeah.
you're removing the file marks, but
Yeah.
you're doing it in such a way that every pass is hitting in the same exact spot.
Yeah. Yeah. No,
Oh
that's
man,
gotta be a way to do it. Yeah, I'm not familiar. I've never filed a bevel. I can
I think
I could
everyone should do it.
I think it'd be cool.
Yeah,
Honestly, I kind of want to try it someday just for the fun of it.
yeah.
But okay, so tell me, after a file, what's the next way you could imagine doing it?
I think for if we're doing kind of like this bird's eye view of knives, I think probably there's a lot of knives that have been made on like a stone bench grinder,
Yeah, I see what you're saying.
right?
A stone wheel on a
Stone wheel, yeah.
generic bench grinder.
In
Yeah.
like your anybody's grandfather probably has one on their
A wire
workbench
wheel on one
in
side
their
and a
garage.
stone
Yeah,
on the
wire
other
wheel on
side.
one. Yep. Take rust
Yeah.
off of like lawnmower blades and then sharpen stuff or
Yeah.
like
Or
grind
weld a
things away. I
rusty
think a lot of
piece of
knives.
metal.
Yeah,
Yeah.
exactly.
Yeah.
So that would be well. And the interesting thing is that each of these, I think, has an area in history where they were actually the preferred method.
Hmm.
So you have a time period where I think files and scrapers. So like the Japanese use a tool, I think it's called a sen. It's almost like kind of like a draw knife made of steel, and they can use that on bevels, but they also use stone grinding wheels. The French use stone grinding wheels. They use stone grinding
Hmm.
wheels in what now I'm going to completely like space on the name in England.
Manya. No, you're not. You're talking about
No,
England.
no, yeah,
Oh.
yeah, like the traditional, like where all the slip joints were coming out
Oh,
of around like
yeah.
the turn of the century.
No, I can't
Sheffield,
remember.
right?
Sheffield. Yep.
So like
Hmm.
Sheffield. So those were stone grinding wheels,
Yeah.
right?
Maybe it was you that told me. Someone told me this. Those big stone grinding wheels. I've seen pictures where they have ones that are like 6 feet in diameter,
Oh yeah,
and they're like you're like on the second story
yep,
grinding on a wheel that's below you.
yep.
And
It turned by
I
water a lot of times,
yeah,
so they'd be on the river.
yeah, and I've heard also that like it is in a water bath, so as it's
Yep,
circulating, you've got water like water
yep,
falling over the top.
yep.
And I've heard that in those factories, they had to have them turning 24/7, 365, because if they sit still, only the bottom gets waterlogged
Oh,
because they're porous, and then they will not turn. Like you can't get it to start turning again after one side is waterlogged and the other half is dry.
right,
And so, like back in the day, they would have to run those things 100% duty cycle all the time, even at night when no one's there, so
right.
that they
Just
don't get stuck. Yeah,
makes perfect sense with water power too, because like the
yeah,
river's not gonna
hmm,
stop.
yep,
Um, Yeah, and like on those big wheels, a lot of times like we grind standing or sitting in front of a grinder. A lot of
hmm,
those guys would grind laying down
yeah,
in on top of the wheel.
yeah. Have like a
And there's like
saddle.
yeah,
Yeah,
kind of or like kind of like on boards, and then they would bring dogs in and put dogs on the back of their legs to keep them warm.
yeah. I've seen that picture. It's crazy.
Yeah, it's crazy. So okay, so bench grinder, modern equivalent of a process that was actually used fully in industry.
Yeah, the stone wheel
The
bench
stone.
grinder.
I'm super. There are modern makers that are using stone wheels. I think a lot of times they come out of like a Japanese discipline or training.
Yeah.
I want to say Murray Carter
Mm,
has some like does grinding on stone wheels.
mm,
So it's like really cool. Yeah, and there's a few like modern Japanese makers like outside of kitchen knives that are
yeah.
doing it too.
Yeah.
So
So
I
you
don't know.
think that's how like a vintage like 15th century katana, like a Japanese sword, would have been made, was with a stone wheel? Like
I
obviously it's
don't
forged.
know. No, I think that was all essentially handwork.
Oh, really?
File
Mm,
scraper stones. Um,
yeah.
well, and
And it,
that's something else. If we're talking bevels, like we're talking purely stock removal at this point, removing
mhm,
metal. If you're forging and you are, you have a high level of like efficiency or like technique, you can forge a bevel in almost to fin. I mean, people forge to an edge
yeah.
almost and then
Yeah.
sharpen.
Yeah,
Um,
I feel like what most people do with the forging side of things is they forge it and they add like 50% of the bevel with the
right,
forge, and then
right,
they grind the finish of the bevel. So it's
yeah,
like at the end of the day, they're doing it the same end process, but
right.
they're arriving in a different way.
Yeah, I love the forge to finish stuff. To me, that like
Yeah.
I look at it, I'm like, it's so beautiful and shows like such a high level of skill to be able to
Hmm.
like essentially shape the entire knife under a hammer. It's
Yeah.
rad
I don't
to
know
me.
much about forging. I really
Me either.
don't.
Me
I
either.
spent a week in, or part of a week in Shane Taylor's shop. He's
Oh,
a
nice.
master smith.
Yeah.
We made some Damascus and stuff. That was really cool. But I'm not super exposed. I'm the stock removal guy. I'm just one of those like computer dorks that makes square steel into a triangle steel.
Yeah.
Like,
Any means
but
necessary, man.
right. So
Okay.
anyway,
Now belt grinders.
belt grinder is the king. I mean,
Right.
it's
It's
the
the
way.
industrial king. Yeah.
Yeah. And so it's like you'll even see them in like Benchmade's factory for sharpening. I mean, it's
Right.
all the way from like the guy's first knife he ever made to Microtech to Benchmade
Right.
to, any manufacturer is going to have at least some of those somewhere. Not
Yeah.
necessarily to do the bevels, but sometimes put a satin finish on a finished knife,
Right.
or something like that. But
Yeah. They're just workhorse machines
yeah,
that have, even if you went to like, yeah, full CNC grind or something, there's still a place for a 2x72 grinder
yeah,
in your shop.
yeah,
And as a new maker, it's one of what I consider like the holy trinity of knife making,
hmm,
which is 2x72 belt grinder, drill press, and bandsaw.
yep,
Like if you have
yep,
those three tools, you can make a living making
hmm,
knives,
yep.
you know?
Absolutely. And it's
So
like the beating heart. I mean, it's the one thing that I don't even
it's,
know what it would be like to not have one to try to
it's
make knives. I
crazy.
mean, the with the
Yeah.
filing and stuff, I mean, it's a totally different ball game. But yeah, so I've got a Travis Wirtz TW90 that does horizontal and vertical,
Yep.
which is really handy. And
Such fantastic
it's
grinders. I've
I've
got one too.
had it for 7 years, 8 years, and
Yeah.
it's just worked. Like it
Yep.
just is good that it's such a cool system. And like I have people come by all the time, like, hey, sharpen my lawnmower blades, or like my I guess it'd be my sister-in-law's dad, whatever that makes him. He's a veterinary practitioner, like a PhD veterinarian
Uh-huh.
for like equine stuff, and he has to do like tissue samples, and so he has these big needles that are like quarter-inch diameter,
Oh,
and I was like sharpening all of those for him on
oh,
my
that's
grinder
horrible.
just like a week ago, and like I feel like I've chamfered like 2x4s. We built like a
Yeah.
bunk
Yeah, I
bed,
do that too. I'm
and it
like,
just like pretty much anything that you can imagine putting like a chamfer or a bevel on, you can do it
right.
on a two by 72.
Yeah. Well, and
They're
Travis's is
awesome.
like super flexible too because of the fact that it can go horizontal. So
Yeah.
if you're gonna have one grinder, a machine that has multiple capabilities, which they all do, because you can
Hmm.
run contact wheels, you can run flat platens, you can run a flat platen with a work rest, you can run
Hmm.
small wheels. So essentially, like all the contouring, like on a knife, like can be done on one of these machines,
Hmm.
right?
Yeah.
Incredibly valuable.
Yeah. And so, like I said, I've ground a like there was a when I first bought the grinder, that was really my only tool. That was my starting kit. Like you said, I did get a bandsaw and a drill press, and I made knives for a few years like that. And it wasn't really like my main staple of my business. It was just something I was also doing, and on top of designing knives. and I got pretty good at grinding with that. But we're gonna start leading into the part of the conversation where it's like automation and repeatability in the way that I'm doing it
Mm-hmm.
is kind of the next step. And I just found with my personality type and the way that I think, like I didn't love grinding bevels on a 2x72. It's fun and rewarding, but then to do it 50 times in a row, like it just didn't, I just couldn't do it. And there was actually like a 3 year gap where I just didn't make any knives because I wanted to do something different and it wasn't feeding my fire, I guess.
Right. You're process driven and you focus on efficiency. So I think for you, a lot of times if you see that you're doing something, you're like, this isn't the best way to do it.
Yeah.
It
Yeah.
takes the juice out of it,
Right.
you
Right.
know?
Yeah. Yeah. It kind of, got to me, and I eventually, like I said, kind of put a pause on making knives. And now, I guess I haven't thought this through, but I guess the next thing beyond a 2x72 would probably be some form of milling bevels.
I actually think that we're jumping over a step, which is
Which,
weird
which one?
because for a long time, industrially, okay, at least knife making, well, okay, yeah, there's two. The next step after like grinding on a 2x72 grinder or some type of grinder, there's like different
Yeah.
sizes and shapes
Yeah.
and 6x48s, but like some type of powered belted grinder
Hmm.
would be the like truly industrial machines, like the burger
A
grinders,
burger. Yeah. Or a
right?
Seatman.
Or a Seatman. And
Yeah.
we're
We're talking
talking
half a
half a
million
million
dollars.
dollars. Yeah.
Yeah.
Okay. So that was
And,
you. That's like you would go to a production facility and that's what they would have,
hmm,
right? Like
yeah.
Boker has one, you
And it
know?
used to be there was not much in between.
Right. There was the
Um,
gap was huge.
yeah. So it's like you were either a custom maker doing a 2x72 thing, or even manufacturers. Like, let's say you're like a bussy. It's
Right.
like they're probably doing all that on a 2x72.
Yeah. There was a
Um,
lot of hand grinding still in
yeah.
production side.
Yeah. And so
Right.
the hand grinding was like even reaching into pretty good volume production. And
Right.
then, like you said, there's the Benchmades of the world that they've got their Seatman or their burger,
Right.
and they're running, it's like 45 seconds per side on the bevel, and they're just like have an operator loading it. And those are very interesting machines, really complex. Obviously, for a half a million, you have to be, that's justifiable in some way. There's a lot
Right.
going on there.
So
Um,
the midpoint for the maker was essentially a shop that focused on blade grinding,
yeah.
right?
So you send them
And
out.
yeah, so you could send out a batch of, if you're going to do like a production run, you could send out a batch of 200 blades and you could have them flat ground by CNC.
Hmm. Hmm.
And
And
there's a
to
few people in
clarify,
the United States that do this.
yeah, the Seatman and the Burger, to clarify, are CNC machines.
Right.
They are computer controlled, servo driven. Like they're doing the motions
Grinding machines.
automatically.
Right.
Yeah. So we're not talking about some kind of mechanical device. Obviously it's mechanical, but it's controlled via computer. And so that's where we're hitting a quantum leap of like the 2x72 leaves off, and after that it's all CNC.
Right.
In terms of moving up in technology and efficiency.
Right. Okay. So there's two stages. I got a weird futurist one, but
Okay.
I also think I have the entry point into kind of where your head is at now, right?
Hmm. Hmm.
At a point, as you saw CNC coming more and more into the market, makers were obviously looking at them and going, how can I do a blade bevel being
Hmm.
the crux of the knife? How
Yeah.
can I do this? I think one of the first makers that I remember seeing something was RJ Martin, and he had done this thing that looked like he left the grooves, like he showed the work, which
Oh,
I always thought was so
yeah.
cool. Ball and mill,
You're talking about
vertical
literally
grooves.
using a CNC mill
Yeah.
and a tool that is spherical on the end,
Yes.
a ball end
To
mill,
remove material,
and leaving grooves behind that look
leaving
like,
grooves showing like how this was done.
yeah, yeah.
That's actually pretty commonplace now. Like you see other makers
Hmm.
doing it,
Yeah.
but I think that was like one of the first uses of kind of CNC milling of a blade that I had
Hmm.
seen.
Hmm.
And then for years, there was a bunch of variations that were like, it's just not quite there. Like
Yeah.
essentially, a good machinist would go to make a knife and they would be able to mill the bevels, but the bevels left something to be desired
Yep. Yep.
for the most part.
And
Do you agree?
yeah, no, for sure. And just to clarify, milling, like from a definitive terminology standpoint, is you're turning a tool that has like a quantifiable amount of cutting edges. So it's like 4 or 5
Right.
cutting edges, and it's rotating and cutting chips of steel, like literally at a microscopic level, cutting pieces. Whereas
Right.
grinding, you can use a mill to grind, like a milling machine,
It would,
where
but it
you,
would be,
but
you,
it'd be,
it wouldn't
it's
be considered mill. It's like the cutter
yeah.
definition.
Yeah, the actual cutter itself is what, in my mind, defines a milling operation versus a grinding operation. So
I would agree.
a grinding operation involves if you can imagine sandpaper or stone, it's like a literal abrasive grit, and
Right.
it's not like a quantifiable number of cutting surfaces. It's like an infinite amount. It's like a million little tiny sharp pieces of diamond or
Right.
silica that are cutting. Whereas a milling tool has like 5 flutes, and it's like a drill bit that's machining, and that's
Right.
where you get those ball grooves, like you're talking about, is like it's cutting a path many times along the blade, and what we call in the machining world surfing. So it's like step over, step over, step over,
Right. And you
milling,
can
milling,
either have a
milling.
big step over or a small step over.
Yeah,
Big step over, like what RJ Martin was doing back in the day, might have been like a 1/4 inch ball end mill cutting a groove and then
like 20
moving
thou.
over 1/8 of an inch,
Oh, geez,
like
wow.
leaving like a visible groove. Right.
Yeah,
So that would
yeah,
be like the macro version of a step over, all the way down to like, I don't know, you're doing like 1,000 step over,
yeah,
you
yeah.
know?
And so that's where I'm doing my bevels right now on the Overland in a system that I really like. I think I'm not going to be able to scale it fully, so I've got other kind of concepts waiting in the wings that we're going to talk about in a bit. But right now, I'm milling the bevels with a what's called a bull nose end mill. So it's not a round ball on the end; it's flat on bottom, but it has like round shoulders, and it's milling across, but with, like you mentioned, a really fine step over, like tenths of thousandths of an inch, so that you can't actually see where the mill had traveled. The It's like the resolution is so high that it becomes like a smooth finish. And
Almost
then
blends it.
I use a stone, like a literal handheld stone with a given grit, and I stone out the final little tiny artifact of like where that mill had passed. And so there's those little tiny micro tiny steps that you can't really see, but you can feel with like your thumbnail. And then I take a stone and by hand just remove those little steps, and that's how I do it. And it's where some people are going, I think, these days. And me personally, I saw a lot of people who have milled bevels with those grooves. I think it looks cool,
Right.
but it has to be a very, in my opinion, specific knife to use that, because
Agreed.
it's like it seems like to me such a compromise on cutting performance that it only makes sense on like specific things,
Right.
you know?
Yeah, it's
Um,
like it's almost like a sculptural element sometimes too. I
yeah,
feel like
yeah.
where you're making a design decision that's not based purely in function.
Yeah, like Les George, he does a knife like that, and
Yep.
he was an EOD technician, like a demolition expert in the Army or Marines. He'd probably
Yep.
be mad that I said Army, but
Yeah. He's
uh,
gonna kill you.
yeah, but yeah, I'm about to feel some ball and mill grooves in my gut. But no, he makes a knife like that, and he it makes sense the way the knife that he did it on is he calls it the EOD tool or something like that. And a lot of what EOD guys are doing is actually digging, and
Right.
so the knife is really flat and broad with like a big tonto, and it's like they're not processing like a half piece of beef or something. They're not like
Right.
scaling a fish. They're like digging with a knife, and so it's
They're
really
using a
thick.
knife incorrectly,
Right.
essentially. So it is a knife by definition, but
Yeah.
it is like more of a prying, scraping, digging,
Yeah.
destructive tool.
Yeah,
Right.
exactly. Yeah, for field work in the nature
Right.
that they do it. And so that it's got ball and mill grooves on it, and I think it looks cool. I think it
Yep.
works. I think it makes
It fits the
sense.
design, right?
Yeah, yeah. And so that's I can see that being application specific, but like I've been making the Overland, which is like I consider a food prep type application and like a fine woodworking type knife or kindling and such. And it's
Sure.
like I just don't want to add the friction, so I make sure to take it all the way down to where it appears. I believe if you were to look at my knife, you could easily assume that it was ground, like on a 2x72.
100%.
So
It
that was
looks
my
like a
goal.
ground blade, which is impressive. And you're also reducing, like if I go to grind a blade, I'm using multiple grits and I'm using a belt progression. So it might be
Hmm.
like 60 grit, 120, 220, 400,
Hmm.
and I might be going to a Scotch Brite belt or some other like hand finishing process, something like that. If you're going to a mirror finish, you're going higher, you're going up to 2000 or something like that.
Hmm.
Your progression right now is 3 steps, which is amazing because
Yeah.
you've got milling, hand stoning, and then whatever your final finish is.
Yeah.
So two
Yeah.
steps really before you have a finished
Yeah.
bevel,
Yeah. Something ready to tumble for a
something ready to
stonewash
tumble.
finish.
Yeah.
Yeah. Yeah, and it's worked really good for me. I've done hundreds of knives that way, and it's like it's working. It works really good. I've got my new machine now that I haven't done bevels on yet, and I'm getting to that point. I'm building the fixture probably next week to start doing that, and I'm curious to see taking it to the next level how that'll go because any kind of chatter at all can appear there, and I
Hmm.
don't know. I was having good luck with the Tormach, but I'm curious with the Sile if I'll see improvement and what that could be, but I know it's going to be faster. And the reason for that is if I mill the bevel in CNC milling or any kind of milling, there's two types of cutting. There's climbing and then there's conventional, which is a little confusing. But if you're imagine spinning the tool, if the tool is spinning clockwise and you're looking down at the part and it's coming along the edge of the part, climbing means it's spinning clockwise and it's also moving in that direction. So if you can imagine like the tire of a car on a road, like it's spinning in the same direction that it's moving. Granted, in with the cutter, it's spinning faster than it's moving. It's probably a little hard to picture through audio, but conventional
I
would be
think
the opposite
the
direction.
wheel, like car on like a tire on pavement, is like a pretty
Yeah.
good example.
Yeah. Whereas the opposite would be like, let's say you're in a car and your tire's spinning backwards and your car is moving forwards because it's being
Yeah,
dragged.
you're
That's
skidding,
like, yeah, that you're skidding.
like
So it's like,
essentially.
yeah. And so long story short, for me, you generally want to only do climb milling on a CNC. And so I climb means I go one way and I can't just go backwards and go back to the beginning.
Right.
So I have to lift, move back, drop back in, and then climb across again. And obviously with those tiny step overs, it's passing across the blade, hundreds of times.
Yeah, four
And
inches.
yeah, and so every 4-inch travel back to home to start the next pass is pretty slow on the Tormach, and the new machine is 4 times faster in what's called the rapid movement. So that means non-cutting, just going through the air. So that air pass returning 300 times per knife or maybe 800 times per knife is going to be way faster. So that's kind of where I'm headed, is maximizing the efficiency of milling bevels to the point where you don't know that it's milled where it appears ground. And that's what I'm trying to
Yeah.
accomplish.
How you right now you're doing flat, like
Flat
true
grind.
flat grinds.
Yeah.
Okay. Um, Process theoretically works with hollow grinds.
Yeah. Yeah. It could, however I design it, it would do whatever that is. And
I'm
that's
excited to
another
see that.
point is with milling is like you can, with grinding, let's say on a 2x72, you've got your round wheel or your flat platen, and the blade is generally going to assume the shape of the backing behind the belt. It's
Right.
flat or it's round or some
Right.
combination of the two,
Yeah,
depending on what
or
you do.
like, and there's ways to create, like you can have a platen with a radius,
Hmm.
and that'll essentially fake a very
A
large
large
contact wheel.
wheel.
So you could have like
Yeah.
a 36-inch
Right.
radius platen, or you could have a slack belt system or something that allows it to create a convex,
Hmm.
right?
And
So
with
a lot of
milling,
flexibility.
there is no confinement of what
I
the shape
know.
of the platen is or the wheel. So you could have it be a flat grind for the first quarter inch, and then be a hollow for the next however long, or it could be parabolic, or it could be. I've
Yeah,
even thought about like imagine at the choil area if it was hollow, but at the tip it was convex, and the
right,
transition was not a combination grind where there's like a seam. The
right.
transition was organic. So like if you look at it in the light, it would be like going from shallow hollow to like shallow convex over the length of
And
the
you
blade.
just completely killed anything that I consider good design.
Well,
Not to say like that's a personal preference, but like
right.
as you were describing it, I was like, I don't like this.
Oh yeah, yeah.
Like,
Eye twitch.
yeah, it's
Yeah,
like that very fluid. Yeah, we're getting like, oh, is this
yeah,
a propeller from a plane?
yeah. No, it'd be yeah. A propeller is a good example though. Is
It's
like you
like,
see that contour.
yeah,
It's
it's
like
like biomechanical
yeah,
almost.
yeah. It's like it's whatever you want. So that's I do a flat grind because that's what I want. But I could do other things and other knives if I felt like it. But I haven't decided to do that. But I digress. Milling bevels is a good way to do it. I think
Right,
technology is getting more and more affordable, especially milling machines in general. And I
right,
think a lot of people are milling bevels these days. And I
right.
think that's like compared to 10 years ago when I started, it was a lot more rare than it is now. And it's common and it's a good way to do it, but it takes a lot of R&D. But it's similar to with grinding. You learn the freehand or even jig grinding. The skill takes a long time to develop.
Yeah.
I will say on a CNC, it's probably just as long a learning curve to do it on the CNC. Like it's as far as getting the first part off, I don't know that it's any faster than getting somewhat proficient at hand grinding.
Well, and
It
here's
takes a
this
lot of
ties
effort.
into something that I think, I don't know, this it feels very familiar to our industry, which is like we like to do things ourselves.
Right.
So yeah, you can just send blades out. If you have a run that's larger than you are going to hand grind by yourself, you can send them out for CNC grinding.
Hmm.
What you're doing is essentially saying, I want control over this process and taking the time to learn how to do that with the tools that you have in your
Right.
shop.
Right.
I think for a lot of makers, it's a more interesting process because it's a
Yeah.
personal process. It's done in
Right.
house,
Right.
right?
Right.
It's not,
Yeah.
it doesn't make it the most efficient. Like almost always, just outsourcing is going to be
Yeah.
more efficient than doing it
Yeah.
in house. That's not the
Yeah.
reason why we do things in house.
And that circles, like I said, back to the point that I've made multiple times on this podcast of like it may rub some people wrong, but I think the person who puts the bevel on the knife made the knife. Like
Oh,
I
that's
I
pretty
just
interesting.
I just feel that way because it's like I'm not discounting like if you send out for grinding and you
Yeah.
do a whole batch, but like for me and the way that I feel when I look at a knife, it's like
Right.
if I didn't do the bevel and it had my logo on it, I would feel like that's fine, but it's a production knife that I didn't make.
That I think
That's how it
that's
would
the
feel.
distinction. I think for me
Yeah.
in the past, it was a distinction that was where production or
Yeah.
at the very least mid tech started to come in.
Right.
At the
Right.
point where you were having a blade ground outside of your own shop,
Yeah.
that was, I think, where a lot of makers were starting to make that
Yeah.
distinction.
Yeah. That
Um,
that bevel is like you said, it's the difference between a custom maker and a production knife is like who did the bevel,
right. I
in
wonder
some ways.
generationally how some of this stuff is going to change. Because I was like, my generation of makers, we were coming in as some of the older makers were like guys that are my age now, probably
Mhm.
were
Mhm.
starting to like CNC was becoming more of a thing,
Yeah.
right?
Yeah.
They were like, this is rad. I want to learn how to do this. I can make sweet
Mhm.
knives on it. Like,
Yeah.
and it was, people were struggling with it because people were
Mhm.
saying like, it's not custom, it's not handmade. Like, we're kind of past that in a lot of
Yeah.
ways.
Yeah.
So what is the 20-year-old maker coming into the industry now seeing that is just going to be totally commonplace
Mhm.
for them?
Yeah.
Can I give them my futurist idea?
Okay.
It's like a
Let's hear it.
weird half. Okay.
Yeah.
Instead of milling, okay, imagine grinding by hand, but using a robotic arm.
Like a robotic arm on a belt on a
So you
2x72.
have your 2x72, or what it could
Mm.
be. It could be a stone. It could be a same thing. There's
Yeah.
a learning curve, right?
Yeah.
Because
Yeah.
there's material wear. There's like how many blades could you get out?
There's
Okay, but
pressure. Yeah.
essentially you are putting a knife into an arm that moves the same way as like a human
Yeah.
hand.
Yeah.
Okay, and you are programming that motion.
Yeah. Did you know that's how Leatherman sharpens all their knife blades?
I did not, but that,
They have like Fanic robots in cages. It's sad. It's kind of like
wow.
like a zoo, with like all these yellow
It's like a
animals like
robot
doing
farm.
work in cages. Yeah. But no,
Oh
they
man.
literally they have like this tumbler and like all these knives like rattle into like their little positions and this robot
Robots pick them
arm is
up.
picking them up, sharpening them on a 2x72,
Yep.
doing the two passes just like a human would,
Yep.
and it's like sharpening them. And it's doing exactly it's not doing the primary bevel
Right.
like the actual
But
main
it
bevel, but
actually like it, and I'm sure by this point I would guess someone has probably actually done
yeah.
this.
Yeah.
And I don't think it's an efficient thing. I just think like
It'd
for a
be
certain type of maker, you're like,
it'd be
yeah,
cool.
I've got like my robot grinding a
Yeah.
blade.
I could see Gavin
Like,
Hawk doing that.
right. Yeah. Just
That's
because.
sounds very Gavin
Like,
Hockey.
yeah, it does.
I'll have to ask him if he's thought about
Yeah.
that. But
Oh man.
no,
So
that's interesting.
that is like one thing that is combining the two, which would be like
Yeah.
freehand grinding and CNC
Yeah.
programming,
Yeah.
used in a
So
non kind of linear fashion.
here's another category, and this is a category I'm investigating and I'm moving towards. So we've talked about 2x72, we've talked about milling, we've talked about Seatmans and burgers that are $500,000. And just for perspective, like a milling machine that can do bevels, like if you're buying like an old Fadal that can do this, I mean, you could be doing that for 10 grand out of pocket. You
Right.
know what I mean? Like it's possible. So it's like the barrier of entry to mill bevels is actually not that high. I mean, I spent like 4 grand on my TW90. You could probably buy like a used machine for not much more than that. That
Right.
in theory you could get to mill bevels. So it's not
And
like
if that was all it did,
yeah, it's not that
that is
crazy.
now your essentially blade
Yeah,
grinder,
yeah.
right? Do
It's
we
not
need? Is
that.
there a different term? Is
Uh,
it like
well, if it's milling though, so it's still
yeah?
just milling blades, not grinding.
I
So
know,
I
but
still
it's
call
not
it
the
the
mill;
grind
it's the
because
blade
people
grind. Yeah,
it's the blade
it's like
grind,
yeah.
but that's just like semantics, I
I
guess.
know it's me.
Yeah, yeah.
But
But
yeah,
the
is it beveling or
right,
is there a term that will come about because of the process? So
yeah,
is it contouring or beveling
yeah.
or
I say I mill the bevels,
mill bevels?
and
Yeah,
but when I show someone the knife, like sometimes I'll call it the grind because it's
right. It's a flat
anatomically,
grind,
it's what people call that part of the knife is the grind.
right?
But so,
You
but what
know,
I was,
can I throw in a weird one?
yeah,
Okay, you know, hand rubbed finishes.
hmm
I hate that term so much.
yeah,
It's a grained finish,
yeah,
right? Like in
yeah,
metalwork, it's a grained finish. It's a
mm,
linear finish applied
yeah, the abrasive,
with grain,
yeah,
with abrasive.
hmm
I think a grained finish sounds so much better than a
yeah,
hand rubbed finish.
yeah, I agree.
I have
And
put it on a few knives. Like I'll say like this is a grained finish, but it's so commonplace to just call it a
yeah,
hand rubbed finish.
yeah, yeah.
Okay,
But
that's all.
what if it's a robot doing it? Then is it still hand
Still a
rubbed?
grained finish. Like grained works. Now it's yeah,
Yeah,
it's robot
it's
hand rubbed finish.
yeah, it's my Fanic finish.
Yeah.
But yeah, but but anyway, there's your like I said, theoretically $10,000 mill that could do a mill on a mill the bevels. You've got your $500,000 burger and Seatman that are way too big to fit in a normal shop, way too
Right.
expensive to afford in a normal shop.
And actually limited in the fact that I think they might make one that do hollow, but for the most part in industry, it's a flat
Yeah,
grind. Okay.
yeah. But what I'd like to bring up is there's a middle category that's emerging, and it's what I'm moving towards, and that is a grinding wheel that is a circular wheel in a mill. So like a CNC mill that has a grinding wheel as opposed to a milling cutter. And so
Right.
it's a hybrid of the two. So it's like you're taking the grind because long story short is that grinding always leaves a better finish than milling. That's just like the nature of all things CNC and all things in general. Like if you buy bar stock that's round, if it's turned on a lathe, it has a step over, it has
If it's
little
ground,
edges.
precision
You can
ground.
if it's precision ground, you could almost like brush your teeth looking in it like a mirror. Like
Yeah.
it's just grinding is always better. And so if you can use a mill and it's like XYZ motion to grind the bevel, that's what people are doing nowadays in certain shops. And Chris Reeve, they're totally open about it as far as I know. That's they invented that as far as I
They
can tell.
pioneered the process. Well,
Yeah.
in this, I love this because it's to me, it feels like such a knife maker thing to do. Like
Mhm.
you're essentially using a piece of technology incorrectly, but
Yep.
you're doing
Yep.
that with a knowledge base that is allowing you to go, hey, I have like this tool and this, tool, and I need this process. What can I
Yeah.
do?
Yeah. You're like tricking the machine into thinking it's milling, but it's actually grinding.
But it's actually grinding.
Yeah. Yep.
Yeah. Big props
And
to
it's yeah,
Chris
so
Reeve.
what is it? 20 years ish, 25
Yeah.
years ish. They've been doing that and they pioneered it and it's
Yeah.
now spreading out and it's starting
Right.
to become more common. And I'm investigating it and I want to try it. The Sile
Yep.
is going to try to grind a bevel at some point, and we're going to see how it goes. But that is the middle ground, like I said, of taking potentially a, let's just be honest, like a $25,000 CNC mill
Yeah.
that's, and then putting a tool in it and achieving a ground finish without buying a Berger or a Seatman. That's where I think the industry is going to head, and
A
I think it's going to happen
comparable
quick.
grind. A comparable
Yeah,
grind. And
and it's
m-
hollow or flat.
and
You can
that
do it.
that right there,
Yeah,
that is such a huge distinction. So imagine
yeah,
that $500,000 machine could grind both flat and hollow. So you're
mhm.
essentially making your, $30,000 mill function like now a three-quarter of $1 million machine, or
Yep,
like a half a
yep,
million dollar machine at base
yep,
level.
yep, yep. And so it's because there's so many manufacturers that are in that size range,
Yeah.
makers and manufacturers, that they couldn't afford a $500,000
Right.
machine, but they can definitely afford like a Haas VF2 with a grinding wheel.
Right.
You know what I mean? So it's like that's where I want to climb into,
Yeah.
and that's what I'm going to be experimenting with, and it's a confluence of a lot of technology and a lot of advancements in the industry, and I think it's pretty cool, and we'll just have to see how it goes.
It's pretty neat the way the flow of information goes. I don't know like why I linked this, but just thinking like as a maker kind of coming up, or you're like making fixed blades, and then like you're starting to do different grinds, and you're like looking at other makers who are doing grinds. You're like, man, that's like, I'll always use Ken Onion as an example, because like if you were interested in those like big swoopy grinds, like on folders, especially, like everybody thinks of Ken. And you
Yeah,
like
recurves and
this
stuff.
progression of trying different things, or like going from fixed blade to folder. I'm super excited because I'm actually getting to do some of that again. Like I'm seeing what you're doing with milling blades.
Mhm.
And for me, like that's the logical next step, like of grinding. Like I have to get my CNC skills and my programming skills to a point where now that is as comfortable to me as grinding a blade freehand.
Yeah, yeah.
And that's super exciting.
Yeah, it's a wild new frontier.
Yeah. Well, and
Yeah,
like 20 years into essentially the same craft, like that's one of the beautiful things about what we do
yeah,
is, I mean, that's crazy. Like all of a sudden
yeah.
there's just like a completely new path
Mhm.
that is related to what you're doing, but like in a totally
Yeah.
different
A
way.
new tunnel of technology opened up, or like
Yeah.
sometimes it's actually different industries that interact with the knife industry, because I would
Right.
argue that cup wheel style grinding in a
Yeah.
CNC mill is actually an adaptation from tool makers. So
Right.
tool makers, by that I mean, like, if you look at the actual, they call it an end mill in a CNC machine, it's made out of carbide. They have to grind that to make it sharp, to have the flutes, to have the shape that you want. And so they have basically CNC mills of some description with grinding wheels in them that grind carbide into that shape. And so this grinding apparatus that they're grinding those tools with is essentially what's being replicated on these knives.
Right.
And so it's actually like almost a lot of the intellectual property that's being used for this is coming from the tool making industry.
Tool making.
And
Yeah.
so sometimes there's other neighboring industries that you see like a crack in the wall and you're like, "Oh my gosh, they're doing what
Whoa.
I'm trying to do and they've been doing it for 25 years."
Right.
You know.
And
So,
they're not looking at what that process can expand, or
yeah,
how
they're
that can
making
be
tools and
used
making money.
differently or incorrectly or anything else.
Yeah.
It takes a knowledge base that's able to link like two processes and go, oh, like if that works there, it could work in this
Mhm.
unrelated process.
Yeah.
It's the
Well, like
biggest reason to have like a varied skill set.
Grimsmo, for example, he's got the Kern, this crazy
Right.
$750,000 machine that a lot of what it's used for is like optical molds and stuff that's
Right.
built to make like hardened steel molds for optical lens grinding and stuff. And so, um, they grind a lot of things with kerns because a lot of surfaces that they're achieving with a grinding wheel of some
Right.
kind. And so he saw that and he wanted to grind the bevels in his kern, which is what he's doing. But he's milling them first and then grinding the last
Oh,
pass.
interesting.
And so but his is totally different because he's using a little tiny, like 1 inch diameter grinding wheel, and he's doing like actual step overs with the grinding wheel. And so there's a lot of ways to come at it. But long story short, grinding is going to be a better finish because effectively when I mill my bevels and I stone them, the stoning is like poor man's grinding to
Right.
like remove the artifacts of the milling.
So
Um,
theoretically, if you're doing this grinding process and you're doing it well, it's dialed,
mhm.
you are eliminating the stoning process at the end.
Yeah. Yeah.
That's
In
one.
theory. In
So
theory.
you would probably still have some type of post processing finish.
Yeah.
Man, so you mentioned Kearns. I had dinner with my friend Keaton Myrick last night. He's a
Mm,
independent watchmaker.
mm.
The watchmaking world to me, like it's insane. If you don't follow him, like definitely look at his feed. But he was explaining like the hydrostatic ways
Oh, yeah.
and like
So cool.
man, like or like yeah, not having essentially like not having bearings and how bearings like always create chatter and just like
Yeah.
so far past like in all honesty, like most knife makers need for precision.
Yeah.
But
Yeah, it's amazing.
it's so interesting
I
to me.
watched a tour of the Kern factory where they were making parts because Kern was an OEM, so they were making parts for like computer companies
Right.
and they were buying mills. And then they realized that there was no mill that could make the parts they were making. So they made
Oh
their own
man.
mill. And so now they sell their mills, but they still make parts for like computer companies. And so there was a shop tour where they're walking through there. I think it was Grimsmo or John Saunders or one of them, and they had made parts that you couldn't see with the naked eye. Like if you had it in your hand, it would be like so small that you wouldn't notice. It's like a flake of like dandruff or something. And so they would put it in a like Ziploc baggie or like between two pieces of tape, almost like a microscope slide, and you would look at it under a lens to see it, and it would have like holes and like little ports and stuff, and you couldn't see it with the naked eye. And they're like drilling these, and they can like engrave human hairs. They'll put a human hair in there and pull it tight, and they'll like write someone's name on the hair and stuff. It's just, yeah,
That's
that's a little bit of a tangent,
insane.
but those things are crazy. So crazy.
Man. Okay. Well, anything else around grinding? So you are starting to learn this process. The process has been developed. You have not done it. This is
No.
your next step. You will
Yeah.
continue to do your
Mhm.
milling process
Mhm.
for your runs of knives while you are developing a
Correct.
true
Yeah.
grinding process.
And the main barrier is the knife has to be held at a really wild compound angle to do this grinding, like certain a number of degrees along the x-axis and the y-axis.
Mm-hmm.
And so those fixtures are very difficult to make. And so
Right.
you have to have it all planned out because if you make, I'm probably going to have to pay someone with a fifth axis machine to make the fixture. And so I want to have everything dialed to where I at least have a really good shot of that first fixture actually working. Because if it doesn't, then I have to change some angles and have it remade, which doesn't sound
The
fun.
beauty, like working in Fusion or SolidWorks, the beauty is you will be able to essentially proof it.
Hmm.
You'll have a very good concept of how it's functioning.
Yeah, geometrically, it should be pretty easy to do,
Yeah.
but there's just a little nuance of like how much grinding wheel engagement, what's the wheel angle relative to the blade. Like there's some, yeah, there's a huge learning curve. So I'm gonna start down that path and just see what
When are
happens.
you digging into that? Because you're busy.
Yeah,
This
that's the
ties into
thing.
R&D versus production.
Exactly.
Okay.
Little callback to our last episode.
Mm-hmm.
That's exactly where I'm at. I've got a bunch of knife steel that I'm working through right now. I'm going to mill all the bevels because, to be honest, I'm not really looking for a better result because I
Right.
think my results are actually as good as I want them to be right now. I just want a more efficient, less labor intensive result. So what I'm doing right now is functional. So I'm going to keep doing it. And what I need to do is I got to get the wheel and get the arbor that matches the wheel, which I
Right.
haven't been able to find off the shelf. So I might actually have to have some sort of custom something interfacing a wheel, a grinding wheel to
This
an
is going to
arbor.
sound weird. I had the idea to use CBN grinding wheels to fit locks.
Hmm.
Just like a lot of people fit them on a belt grinder. I can do it. That's how I've done it for a long time. But I think there's inefficiencies in it, in
Yeah.
that there's
Yeah.
a small amount of flex. So a
Hmm.
CBN wheel is essentially non-friable. It maintains its shape and can
Yeah.
be like brought back to a perfect shape.
Yeah.
So I had bought some CBN wheels and I was like, oh, I wonder if I could like convert this lathe and like build a lock cutting fixture. And I could not find an arbor. And it
Yep.
actually like stopped me in my tracks. I'm like,
Yeah.
it's ridiculous because like someone is going to send us a message and they're like, yeah, this place just has all the arbors for
Yeah.
CBN wheels. Like
Yeah.
obviously it's something that's available.
Yep. Yeah. It's
If
going to take
anybody
a look.
knows, please tell me. Like,
Yeah. That, well, and the other thing is those CBN wheels, they don't have drive dogs, which a drive
right,
dog is like ears on the arbor that
right,
keep it from spinning. And all the shell mill holder style for like a BT30 for my machine all have drive dogs, which you want because you don't
right,
want that thing spinning on the arbor on accident.
right.
And
Yeah. So it might be like a modified, like you
so
do a soft jaw to cut like a dog into the backside of
yeah,
your
yeah,
CBN
it's
wheel
going to
and
be
then
something like
figure.
that.
I
Yeah.
wonder if you could, wonder if you just mount it up to a, like a cat 40 shell mill holder, like you would get one that is large, maybe larger than your ID, soft jaw your grinding wheel, bore it, cut your like
Yeah.
dogs, and maybe that's the
And the only
solution.
nuance there is you have to have perfection on
Right,
the concentricity, or
right,
if it's slightly out, then you have a wobble in your wheel,
right.
which is no
It's
bueno.
going to give you like, it's essentially like having an errant piece of, 40 grit media in your
Yeah.
220 grit
And
belt.
it may just destabilize and the whole thing just comes apart, the wheel. You know what I mean?
It's a
Like
good thing
because
you're
it's
videoing all this
yeah,
because when
right.
your machine
Yeah,
explodes,
but it's
like,
like it balance in a rotating assembly is absolutely critical because like I mean in an engine in a on like a a tool holder, if you look at it, it's got little peck drills around it
mm-hmm,
because they put it on a balancer and it drills material away to make sure it's balanced because the amount of vibration that can spin up when you have out of balance. So that's the only thing is I'm a little worried. I don't want to Mickey Mouse it and then
right,
like get an out of balance situation and having put $500 worth of materials into it and then it
right.
just starts to vibrate and like ruins my spindle bearings or something. So
Is it high
it
RPM process?
not super high, but the
So
thing is
that's
the
helpful.
diameter is pretty large,
Right,
which is just as important as RPM because if you
right.
start to get more radius, you get more
Yeah.
inertia. So
Pump, pump,
yeah,
pump, pump, pump.
yeah, yeah. I
Okay.
don't want to throw
Ooh,
a
man.
CBN wheel, shear a pull stud, and throw a whole tool
Yeah.
through the window. Like, yeah,
Oh man,
yeah.
my brain is starting to like, I'm getting buzzy. That's like,
Yeah,
it's just a
no,
lot of like process thoughts where I'm like,
yeah.
oh,
Well, I think what I'm going to do is buy a shell mill holder that has a close and oversized arbor
yep,
and have it ground to the
yep.
right arbor diameter.
Ooh, okay.
And then all I have to do is mill the dogs into the back of the wheel with some sort of special fixture, because the dogs aren't that critical of a
Right,
milling operation because they're not concentricity
right.
doesn't come in
Yeah, I
there.
feel like soft jaws, like aluminum soft
Yeah,
jaws there would be
yeah.
probably fine.
And then I'd have the wheel and then the fixture. So those are the two main things. And I've thought about also if I can get the grinding wheel on there and then put a hardened blade flat on a in a vise or something in a soft jaw and start grinding on it just to see what happens. Like just do like some skim passes, even though
Right,
it's not a real bevel, like it's not a real product.
right,
Like just start grinding hardened steel and see like how the machine reacts, what different feeds and speeds matter. Am I even in the ballpark as far as like the mass and the spindle of my machine
right.
and that kind of thing? So I got to approach it for sure. It's
Okay.
coming.
We're starting to get into the deep brain work. I've got a meeting coming up here in a few
Yeah.
minutes. Do you want to call this one?
Yeah. Let's call it
All right.
bevels, bevels, bevels.
All the bevels,
Yep.
crux of the knife, many
Yep.
ways to do it.
Yep.
Do
All right,
what
man.
works. All
Peace.
right.
And guys, let us know if there's another way to do bevels that we're not aware of.
Yeah.
I'd love to hear
Lasers.
it.
I don't know.
Yeah.
EDM.
EDM. I've heard of that.
Yeah.
People have done it.
Yeah. It's pretty cool. All right, guys, give us a review. Share the podcast.
Yeah.
I don't know.
Hit
It's
up
much
hit up your
appreciated.
friends and your friends' friends.
Yeah.
And
Force your friends to
their
listen to this podcast.
Tell your mom, dad,
Confuse everyone.
brother.
Yeah.
Yep.
All right. See you guys next time.
All right, peace.
Yeah, later.